Anca Bratfălean.
And I am Diana Petruț.
We are 15 years old
And we live in Cluj-Napoca.
We decided to participate in this contest
by building an integral spacecraft.
These are the materials we will use to build the integral spacecraft. Our aim is that by the end of this video, we will be turning this into this. We will start with the first of the two main parts of the spacecraft, the service module.
The service module is also called the spacecraft's body, and it is a copy of the XMM Newton body. The service module is the lower part of the satellite and contains all spacecraft subsystems. It is a closed structure made of composite material, a combination of aluminum and carbon fiber. It is used for saving development costs and simplifying integration with infrastructure and ground facilities. Nevertheless, an adapter was necessary to be connected with a different booster. The satellite systems, power conditioning and control, data handling, telecommunications and thermal attitude and orbit control are all placed in this service module.
And here is our service module. Next is a smaller part of the spacecraft, the solar panels.
The solar panels, also called dual solar arrays, have the purpose to derive electricity from sunlight. They provide power to run the sensors, active heating and cooling, telemetry, and also power for the spacecraft's propulsion. They have a length of 16 meters when deployed and are producing 2.4 kilowatts. They are backed up by dual nickel-cadmium battery sets.
And after a few more adjustments, we created these solar panels. And finally, we proceeded with the second part of the spacecraft, the payload module.
The payload module is also called the instrument structure and is also composite. The detector assemblies are supported by a rigid base, and the coated masks are held at about 4 meters above their detectors by an H-shaped structure. This is the heaviest payload module ever placed in orbit by ESA, which is because of the need to shield the detectors from background radiation in order to make them sensitive. The gamma rays are detected by two main instruments, an imager and a spectrometer. Two other instruments, an X-ray monitor and an optical camera, will help to identify the gamma ray sources.
And here is our finished payload module. And by adding the last piece, the primary spectrometer, also called SPI, it is now time to put up our integral spacecraft. And we will do that by sticking all these parts together. Now that it is all finished, let's take a little look around our integral spacecraft. We made it at a scale of about 1 to 20 centimeters. We wanted it to be as similar with the real one as it could be. We painted the payload module yellow and made thin white lines along the solar panels so it would look as realistic as possible. We hope you enjoyed.